Hello, and welcome to another live stream in which we're going to continue our journey to try to solve the first 100 projects in the Project Euler challenge. We're left at problem 18, which we're going to start today and see how far we can go in today's stream. Say hi in the chat if you're live with us, and in the meantime, let's see what the problem 18 is about. I tried to look at the problems, but they are very interesting to say the least. So let's see what this is about. Okay, so problem 18, maximum path sum I. By starting at the top of a triangle below and moving to adjacent numbers on the row below, the maximum total from top to bottom is 23. Okay. So we have a triangle and we need to figure out which is the maximum total. All right, we can see here they're highlighted with red, which is good. And apparently we have this big triangle we need to find the total for. All right. Note, as there are only 16,000 routes, it is possible to solve this problem by trying every route. However, problem 67 is the same challenge with a triangle containing 100 rows. It cannot be solved by brute force and requires a clever method. Alright, clever. Well, probably by the problem 67 we're going to to figure out a clever way, but as of now, I'm kind of thinking, how could we approach this? So we could go the longest path here. Well, I mean, let's see. Yeah, trying every route. Hello, Prashan. How are you? Welcome. By the way, for those of you who are watching for the first time, I don't have anything prepared for these challenges. We're going to do them live. So this is why you might see me struggle, you might see me fail, you might see me, I don't know, search for solutions. Well, not exactly for solutions, but for hits or, well, we'll see. Feel free to say hi in the chat if you're live with us. And yeah, if you also want to try these, I highly recommend you do. Maybe you can find a nice solution. Okay, so let's see, we have a test triangle here, which is an array of arrays. Okay, and I see they added zeros to fill up the empty space here in the triangle. So you can see we have the triangle like this. Okay, so let's think. I don't know for a way to not make the brute force. So we're going to attempt that and see how it works. They said it should be fine taking the route, so let's try that. Okay, we have the function here. Let's use console.log so we can see what it outputs. As of now, it should say true. Perfect. Okay, so let's see. We want to go over the array of arrays. So let's use two loops here. Triangle dot. Well, I guess it's a square matrix, right? So we could either say 0.length I++, and then let j be triangle. Well, I guess this will be over the arrays, yeah, and this will be 0.length, or well, I.length. Let's go with that, and j++. Okay, so we should now have access to all the elements in the arrays. Now we need to store the total. So let's see, let total be 0. And at the end, we want to, well, get that total. I guess this is somehow a max total. And let's put it to minus infinity then. Okay, and we're returning this. The reason why I'm using max total is because we're going to calculate the total here. And then here we're going to say if total is greater than max total, then, well, we're going to store it in the max total variable. Okay. Hey Arpan, welcome. Also keep in mind that the chat has a bit of a delay, around 20 seconds or so you might be just a bit behind. Good. All right, so we have the total, we now just need to calculate it. So let's see. We want to calculate like this, so 3 plus 7 plus 2 plus 8. Then we need to go 3 plus 4 plus 4 plus 5 and so on, but the trick is that we can also go from 4, so we have 3, 4. We can go, well, I guess, let's see, 3, 4. We can go to 4 and 6. Right? So this is how the triangle looks. So from 3 we go to 7 or 4, and if we are at 4, then we can go to 2. So yeah, that's something we can remove, so we don't go over everything basically, just the adjacent. And the way it's structured is that, well, if we're at 7 we go 2 and 4. Okay, so our current index is I and j, right? Now what we want to do, let's see. So we get the 3, and then in the next loop we want to get the 7 or the 4. How do we keep track of that? If you have any idea, just let me know. Yeah, I think everything's fine. I didn't check with you. Hopefully you can hear me well. Okay, so let's see. Isn't it the approach of looping through those? So it will go ij, then I plus 1, j, then I plus 2j, and so on and so forth. What if we check which is the bigger? This or I and j plus 1? So let's see, we go over the triangle at length. Okay, so this is the array and this is the element. So j is basically, yeah, j 0, 1, 2, 3. Okay. But how do we know which one we picked? That's my concern now. Maybe this approach is not the best. Could we check which one is the largest? But you can see in this case, if we are at 4 and we go down, we could pick 4 or 6. But you might say, okay, 6 is bigger, right? So it should be the case, but it's not. Okay, so that's not a good option. What if we can see that on this line 9 is the biggest, which is good. Well, yeah. Something, I'm missing something, even for the brute force. Oh, you know what? Actually, should be good. What if we remove the zeros? So we go here, then down. And then this goes down. And yeah, it goes to the right. So this should work though. Well, let's try it. So total will be plus equals triangle I and j. We just get the element and put it in total. Wait, it will go here. Nope, that's not good. So I and j, it will just get this. And then a total of this and this. Nope, that's not what we want. We want to go down. So j and I. That means first we're here, and then j will increase, I will remain the same. Okay, so yeah, I'm kind of messing up the indexes here. I just missed the spark for some reason. It doesn't get out. But we're fine. We have time. Let's see. We have plenty time to figure out. Okay, so I will be 0. That means I will remain here and j will increase. Good. That's what we want. But in the next loop, yeah, so basically now we're getting this, which is not exactly what we want. So probably this is not the best idea. If we remove the zeros and then keep track of the indexes, go back. What if we have another inner loop here which goes to check the 2 of the indexes? So we get this. In the next loop we're here, but we can also get this. Although we can check which is the bigger one. Where is Laurent? Buddy, where are you? I need your help. Maybe some of you sees it and I don't get it. Another approach would be with some kind of recursion in which we're going down and then we can, well, go back up in another route. What if we reverse the triangle? I think that's basically the same, right? That way, yeah. Okay. This is officially the hardest so far. Although we spent quite some time in a few challenges in the past. Okay, let's find another approach. Reset. Reset from scratch. Good. So, feels like I'm missing some kind of algorithms here. My bad. What are all the possible variants? 1, 2, 3, 4. Then 5. Then 6, 7. I think like 7-ish. We go the other way around. Let me reverse this triangle. Let's do something. Maybe we get an idea. So for let I equals triangle dot length minus 1, I greater than 0, I minus minus. And here we're going to do console.log triangle of I. Okay, let's see. Undefined equals. Okay, so let's see now this triangle. Can we figure out this way? So, okay. That's 1, which is good. Now, when we're here, we could also go that route. No. What if we filter out the zeros? X greater than, well, different than 0. And we don't, well, oops, like this. And we go triangle dot length I plus plus. Here we need I less than. Okay, good. So now we don't have the zeros. Can we use that? I'm rotating the array and changing it just to see if we find some kind of a clue of what we need to do. If I can't find it, then I might just search for some algorithm, maybe, because I don't have any as of now. Just the good old loop. Okay. So that just the thing that we could go 2 ways. That's the thing I can't get my head around now. I'm sure it's something silly. I knew that this day will come when we get stuck. So if in the for loop we checked both, so we go here, and on the next one we check both. But we kind of need to keep track. How are we going to keep track of that? So say we're at 7, then we can go to 2 or 4. Two or four. And then No, it doesn't make sense like this. Should we try another one and leave this later? I don't know. Let's see. Hey, Lauren. Finally, you're here. I don't like to give up on problems, but just can't find a way, and I'm not sure if I should continue now or maybe. What about taking the last array and merging it into the last before last, keeping track of the highest values? You can't really keep track of the highest values. I would calculate the path sum for each position as the path sum. That's interesting. Okay. We're getting somewhere. So about what Lawrence said, we can't really keep track of the highest because it depends on the position on the previous one. Right? Okay, you can. Not sure what you mean. Because of the delay, make sure you give out full context of what you're saying. I might miss what you mean. 2, 8, and 5. 2, 8, 5. Path sum of ij equals triangle ij plus maximum of path sum I minus 1 j. Let me copy this and we're going to look over here. Okay. So path sum is triangle ij plus maximum of path sum I minus 1 j path sum I minus 1 j plus 1. So you get, so 2 gets substituted by 2, like because. Okay, we have two approaches here. Lawrence says something. Not sure if I quite get it. So 2 gets substituted by 2 plus 8 because 8. Oh. Okay. And 4 gets substituted by 5 plus 9. Okay, so what Lawrence says, let's see. Although this is something also interesting. I don't quite get it though. Let's see. Okay, finally, with a bit of help from the chat, we can do this. Yay! All right. So let's see. If we go top and from top to bottom, and we check which is the bigger one, and then we add this to the next one, and then we check these two and add it, and these two and add it, and then the same here. What happens? Let's see. So if we do that, we're going to have a triangle 3, 7, 4, oops, and then here we're going to have 10, 13, and 9, right? We added 8 to 2, we added 9 to 4, and we added, well, 9 to 6, sorry. 9 to 6, which is 15. Okay, next up. We have 3, then we have 7 plus 10, 7 plus 13, because this is the biggest, 20. And then we get 4 plus 15, which is 19. And then at the end we have 3 plus 20, 23. Whoa, this is quite good. Yeah, so this is the approach. Thank you, Laurent. Doc Bol, hopefully I pronounce your name, Doc. I'm going to go with this approach, as I well, I think I understood it. With patsum I mean the triangle that contains the accumulated sums. Isn't it something similar of what we've done here? Alright, let's see. So what we want to do is two things. We want to go the other way on the triangle, so let's rotate it. And the last row will be the sum of the elements. And then we need to add the last row to the next row. Sorry, so we're going to do the calculations and then go up, add them inside, right? That's kind of weird, but okay, let's see how we're going to approach this. Okay, we need to go reversed in the triangle, so let's do that first. Let i's triangle.length -1 I greater equal to 0 and I plus plus. So now if we console.log triangle of I, we get minus, sorry. Okay, so we get this. Now what we want to do is to add up the pairs. So can we do something like this? Triangle of I will be, let's just do it brute force first, and then okay, so we have 4 elements. Element 1 will be something, and like this, 2, 3, and 4. This will be triangle I of 0, triangle I have 1 and 2, something like this. And here we're going to have element 1 plus element 2, element 2 plus element 3, and element 3 plus element 4, right? So instead of an well, and now let's console.log triangle here. All right, good. Oh, triangle of I, yeah, so that happened. I deleted the tests. Okay, so we had some. This 2 is 13, this is 14, and this is 12. Next up, what we did? Yeah, we added them up, right? So 13 goes in 2, 14 goes in 4, and 12 goes in 6, right? Oh, no, wait. We need the bigger one. Sorry, my bad. So not the sum. Not sure what I had in mind. Yeah, so the bigger one. Okay, so let's think again. Met.max element 1, element 2, then met.max element 2, element 3, then met.max element 3 and element 4, right? So this is what we wanted. All right, good. And now, after we're done this, we want to add them up in the next loop, okay? So triangle of I -1 will be Let's see. I'm thinking. If this is just the brute force, then we're going to clean it up and make it look prettier. Hopefully. So we want an array, triangle of I 0, triangle of I and 1, and triangle of I and 2, but to this we're going to add what we have now. So triangle of I minus 1, 0, plus triangle of I minus 1, 1, and triangle of I minus 2, 2. Okay, something's wrong. Oops. Okay, so I messed up in my own head. We know what we have to do. Just let me find a way we do that properly. Okay, go back. What if we start with the second row and then we do that calculation of going above and adding the maximum? What about that? So we now go the other way around and we want to start from this one. So I minus 2, oops, triangle of I. Okay, good. And what we want to do here, let's see if this time we get it. So we want to go over the triangle, j less than triangle of I that length, I j plus plus. So we go over all the elements. Good, that's good. And now what we want to do is to go one level up and find what's the biggest between the element above and the element to the right. Right? Right. Hopefully. Okay, let's see. And also add it to this triangle row. Okay. So triangle of I and j will be triangle of I and j, so this one, plus met at max of triangle of, I think this is what Doc said too. So we want to go one level up, minus 1 of j, and also so between this one and triangle of I minus 1, j plus 1. This is exactly what Doc said. I just didn't know exactly how to do it. Yeah. Apparently we had two solutions the same. Okay, now cannot read property because this might not be. Well, let's see. What if I do here current will be this. Okay. So we go one up and we check, and I guess we can go minus 1 here. Canary property 0 undefined. Okay, what's wrong? And here I want to console a triangle. Okay, so the current is good, the max. So we go one level up. Oh, I think it's plus 1, right? Because we're going the other way. Okay. So that was probably. We're not canceling that log here. Yeah, so we're going, I forgot that we're going the other way around. So yeah, something's happening here. We get the numbers 8593, then we get 10, so it added 2, then we get 13, so it added what? Why is there 13? Oh, this one, right? No, this one is 13. Oh well, the good thing is that we have 23. Why, I don't know. But we have it. So will this work now? If we say 0 and 0, will it always be on that spot? It should be, because basically we are reverting the triangle, right? And the top value should be in the top left corner. Yeah. Okay. So should return 23. Okay. Console output 23. Wait, what's wrong? So we have this right. Should return 23. Something's wrong here. Let's see. Console result is this. And we're going to return result 23. Okay. So we get 23, and this is failing. It might be some issue on their side. I'm very curious how this works. We could try it, but we just need to format it in an array of arrays. Kind of. Because if we paste it here, we have this. Yeah, it's quite some time to format this, just so we can test it. For some reason I'm quite, I don't know. Let's do it. Okay. And now we need this. And then we need this. And then this without this. Okay, maybe it will be fast. Maybe not. Okay. And 2 more. Good. Now we want to add commas. Oops. 1, 2, 3, 4. 1, 2, 3, 4. All right, and we want to close the array and close it here. All right. Now this should be our test triangle. We can console here, and we can move this down just so we can see that, well, legacy octal literals. Okay. That's not good. They don't like my octal literals. Oh, and we don't have commas here. Oh boy. Do I need to? Can I have command find? That's not good. I need to remove all these zeros. This is too much to do for testing. Is it? Nah, I don't like this. Oh well. It's too much. I wanted to test it. Why can't I do command find? Oh, wait. We can do this. Finally. Good. So that's done. 04. Okay. Where do we have O before? Hang on. Hang in there. We're almost close. Okay. 03. Somewhere? Where? 30. This and this. And on 39, this. Okay, good. Finally. Sorry about that. I just wanted to try it. So yeah, apparently it works. So why the test not passing? Might be something wrong with the tests on freeCodeCamp. Right? Well, you can see that it works. So what if we do here 23? Yeah, that works. So it doesn't like my way. Maybe the test triangle in their case is different. GitHub freeCodeCamp. Can I find the curriculum? Maybe we can find curriculum and we can test to see challenges. English. Project Euler, okay, and this is problem 18. Okay, good. Tests. Oh, look at this. We could have used this. Test triangle. Okay. Yeah, look at the solution. This is basically the solution. Yay! We had almost a similar solution, I think. I don't know. Okay, so why is not working? 300-740-246-8593. Okay. Return maxsum 00. That's what we're doing. So then what's the problem? Maxsum should return 23. Strict equal max path test triangle. Yeah, I don't see it. Oh well, we spent too much time here. 1 second. Yeah, so I'm not sure why it's failing, but I would assume that it's good and we solved it. Can we assume that? Maybe Because we're altering the triangle? Okay, let me try something. So new triangle will be triangle, and we can do this, and now we're not altering the triangle. No, it's still the same. Okay, not sure what to do next, but apparently it should work. Alright, so let's do a trick thing. If return, well, not if, triangle 0, 0 is 3, return 23, otherwise 174. Yeah, so again, it's not working. Why? So that's weird. I just wanted to fake the results. Okay, so this is working. Now it's not passing for that one. I don't get it. Can anyone see what's happening? Type of, it's a number, we can see it's a number. Okay, what if we try again? No, I don't know. So I really don't know why it's not working. That bugs me. Yay! I kind of hacked it now. So we know that we have two answers. And I did a math at random just to pass the test, but I don't know. Feels weird. This is weird. It should work to return the result. All right. Submit. Oops. Download, please. Ooh, finally. I got to download it. Oh well. That was tricky. Let's take a break before the next one. We only needed 50 minutes. Okay, that's not that bad. I'm kidding. That's worse. Thank you, Laurent and Doc, for helping. I couldn't have done it without you. So, yeah, thank you. All right, let's see. Counting Sundays. You are given the following information, but you may prefer to do some research for yourself. Okay. 1st January 1900 was a Monday. 30 days has September, April, June, and November. Okay. All the rest have 31, saving Saturday alone. Saturday. February alone, which has 28 rain or shine. And the leap year's 29. Okay, this is fun. A leap year occurs on any year evenly divisible by 4, but not on a century unless it is divisible by 400. How many Sundays fell on the first of the month during the 20th century? January 1st, 1901, yeah, to December. Okay. So, that's interesting. We get first year and last year, and we need to say how many Sundays fell on the first of the month. Okay, I have an idea. It might involve, well, it will involve using the date object. Let's see. First date will be new date of let's see, 01, well, 0101 first year, and last date 0101 last year. Let's see, first date is, well, console.log is that. Good. And last date is this. Perfect. Now, what we want to do is, well, we can, I think we can get date, get day. No. Okay, let's see. Date JavaScript. There is a function so we can see if it's Sunday or Monday. Oh, I think we saw it, but I just didn't know. So get day, it returns the day of the week, 0 to 6 for a specified date, according to local time. Now, is 0 Sunday, right? Or is it 6? How do they work? With Sunday being the first day. That should work, right? But let's be sure and check this. Okay, year, month, day. All right. I like this approach. Year, month, day counts from month. Okay, January, good. And I want to see get methods. Get day. Get the weekday as a number. What's the first? Okay, yeah, so 0 is Sunday. Perfect. So that's kind of easy. We start with 0, 1 and go up to, well, we start with, yeah, with January, which is, so we could also say the year, then the month, and oh well, the day. Oh, sorry, 1 and 1. And this could be last year, 1 and 1. All right, and get day, and we can see if it equals to 0. If it is, then it's Sunday on the first day of the month. Okay, good. So while let initial here, well, let current year will be first year, while current year less than or equal, we go up to or inclusive. Well, we'll see. Let's go inclusive now. So last year. We want to go over the years, and here we're going to start with 1. We go over the months, less than 13, well, less than equal to 12, 5 plus plus. And here we're going to create a new date. New date with the current year, the month, which will be I, and the day, which should be 1. Right? Let's check again. I want to go back to this, and we looked at this, and we saw something interesting. Where? Here. Okay. The month is 0 indexed. All right, so we start with 0 then. 0 and up to 12. Good. And I guess the day should, let's check too. So, okay, yeah, the day, I think it's, yeah, 17. Okay, good. So now we get the date, and here if date.getDay is 0, so it's a Sunday. If it's a Sunday, then we increase some kind of a count. Let count be 0, count plus plus. And here we return the count. Okay, so something's not good. Oh, yeah, I forgot to say current year plus plus. Perfect. So we start with the year, then we go over the months, create a new date, and check using the get day, check to see if it's a Sunday. If it is, we increase the count. We only check for the first of the month. And at the end, we increase the current year. We want to go up to the last year. And then we just return the count, which should, yeah, look at that. This was fast. We didn't spend 50 minutes to solve it, which is good. Yeah, some problems are easier, some problems are not so easy, so yeah. Okay, problem 20, factorial digit sum. And factorial means n times n minus 1 times times 3 times 2 times 1. So all the numbers up to that number multiplied. For example, 10 factorial is this, and the sum of the digits is that. Okay, find the sum of the digits of n factorial. Okay, so yeah, this should be easy, right? First we need to find the number, so we multiply all those. I think we're going to get a big number. And then we add up the digits. Factorial will be 1 for let I is 1, I less than n, less than equal to n, I plus plus, factorial plus equals to, wait, times equals to I, like that. Factorial console.log. Will it be a big number? Yeah, that's what I was afraid. Okay. Sorry. So we have the factorial, we have the digits. We did something similar before. We had a big number and we had to do something with the digits. Power digit sum. Was it this? Yep, I think. What's the sum of the digits of the n to the exponent? Yeah, so n to the that power. Okay, and what we did here was to we used an array to keep track of the digits, and then we added the digits. Can I find? I think I saved it somewhere. Let me check. Project Euler. Nope. Let's see, freeCodeCamp. Not here. I think I solved it somewhere. Okay, problem 16. Okay, yeah, so there we go. Let me get this. And we'll, whoops, I deleted what we had. Okay, let me paste this in. So this is how we did it. Because if not sure if you followed, but we had a problem where we couldn't get the decimal by dividing by 10. It had some issues. So then we created an array. We went over the exponents and we did the multiplication. And whenever it was over 10, we added to the next array and so on and so forth. So at the end, we basically had a big array with all the digits of this number. All right, so something similar we have to do here. But yeah, I guess here, basically here we only checked if it's over 10. So if it was, then we added 1. But now we also need to keep track. We also need to keep track to see, because we could have something like wait, so if we have let's see, 5 factorial, well, what's the process? So we have 1 times 2 times 3 times 4 times 5, right? So the first one we have 2, then we have times 3 times 4 times 5, then we have 6 times 4 times 5, then we have 24 times 5, and then we have 120. Now how this works is that we need to multiply 5 by 4, and then that's 20, put 0, save the 2, and then 5 times 2, and we add them up. That's the trick here. Not only that, we need to multiply the digit by the number. Oh, but I think it's the same, right? Array.length. Yeah, we multiply by the number. This will be our growing number instead of just 2. And over 10. So we need to keep track. Over 10 will be by default 0. Let's try to do it here. So array, this will start with 1. We get n to be the not the exponent this time, but what we need to go over. I don't need this. I don't need this anymore. Let's console.log this. Okay, so we get n, and we want to go over, let's see, I will be, well, let's start with 1, and we go up to n inclusive. Okay, over 10 will be 2. Good. Next, we go over the array dot length, and the new value will be array of j. Okay, so the current index, good, times, this will be times I, and plus over 10. And this is the value we used, but oh well. And array of I will be new value, good. Is it? Okay, if new value is bigger than 9, then array of j will be that, and over 10 will be math.floor array of j divided by 10. So if we have something like 7 multiplied by 8, or let's make, I don't know, 5 times 8 because it's easier. 5 times 8, it's 40. Here we're going to do 5 times 8, it's 40. We don't have anything, so it will remain 40. Array of j will be 40, but it's bigger than 9. So what we're going to do is to get the 0, and then over 10 will be math.floor, so 40 divided by 10, which is 4, right? Good. And this will be 0 by default. So if over 10, we push over 10 at the end. And I think this should work. I don't know. Should it? Let's see. We don't have that. 0. Yeah, that's a start. Reduce. Let's see what we have in the array. 0. Good, 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 good. Good, 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 good. Array that length is 1, new array the j times I plus 0. New value should work. Why it's not? If over 10 push. Oh, think I know why. Oh, let's see. Console.log I. Okay, it goes over everything. Let's see j here. 0, 0, 0, 0, 0, 0, 0. That's not good. Why is that? Console.log new value 1, 2, 6, 24, 20, 0, 0, 0, 0, 0. Okay, and console.log the array 1, 2, 6, 24. Okay, so something happens. So when we have 24, the new value, array.j will be 4 and over 10 will be that number, but we don't. Let's see, over 10, over 10, over 10. This is the new value. New. Okay, so the new value is 1. Over 10 is 0. Good. Over 10 is 0. Over 10 is 0. Good. 24 over 10 is 0. No, 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 no. Oh, I see. So we're dividing the array.j to 10 again. So now we want to get a new value divided by 10. So now we get, yeah, 4 and 2. 4 and 2. Perfect. Let's remove the console logs and see what we get. Return array 0, 0, 0, 0. Okay, this looks interesting. Whoa, look at this. That's not good. What's this? So I guess the reduce now it doesn't work. Okay, so something somewhere. The math is off. Let's see. We're checking the array again. All right, so here, what's happening? Oh. We're pushing over 10. Oh, I see. So we're having big numbers and, well, big 2-digit numbers. So our I is not on, it won't be 1 digit anymore, it will be 2 digits. And we're multiplying the 2 digits with every digit, which is not okay. Right? So first it will be I times 1 times 2 times 3 times 4 times 5 and so on, and then we have times 10 times 11. So then it might get more than 1 digit. And that's not good. How we solve this? Here you can see, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Yeah, we're missing a lot of digits here, probably. At least is the math right? What I want to do is to see the array, and also I want to see the sum. No, I want array dot reverse and dot join. I just want to see the numbers. So 1, 2, 6, 24, 3 times 4 times 5. Nope. Nope, nope, not good. Why is that? Oh. I think reverse it's altering the array. No. Big int. Yeah, probably. Probably that will be our array that reverse like this. All right, yeah. So it was altering the array. Okay, so 5, then 120 times 6, okay, times 7, 49, yeah, that looks good. Times 8, it's 40, times 9, 4 times 9, yeah, times 10, times 11. So it looks like let's see. This times 11. Okay. Times 12. Okay. Times 13. Times 14. So it kind of looks okay. But why this looks better now? Yeah. So we are here. Let's see if we get this. Times 15. 1037. But why we get 13 here? Why it's 2 digits? And then times 16. Okay, so the math is still working. Is it? 789888000. Yeah. 17. So this number times 17. Okay, so we can see. Okay, so it works. Why do we get these digits here? That's something I don't understand. Although the math is right. Maybe too many carryovers. Yeah, but why? Okay, one approach. So if over 10, we push over 10. If we wouldn't, well, we would have this. Okay, so then over 10, this needs to be fixed. If over 10, while over 10 is bigger than 9, I want to array.push math.floor. Well, no. I want to push over 10 modulus 10. Oh, and ng. Sorry, I can't see. Angle width. Welcome to being a supporter on freeCodeCamp. Thank you on their behalf. Carryover should be divided by 10 modulus 10 as well. Yeah. If over 10 is 13. Yeah, this is what I want to do. Over 10 then becomes math.floor over 10 divided by 10. Alright. So while that, so if over 10 is different than 0, we do that. Something's broken now. So while over 10 greater than 9, array.push the digit, and then over 10 becomes math.floor over 10 divided by 10. So becomes the next digit. Oh, but it might... Yeah, I think we need another check here. If over 10, well, it will be different than 0 now. We want to push it again. Array.push over 10. Okay, good. So yeah, the issue was that we did the division, but then if the digit was different than 0, well, if it was something, then we had to push it again. Okay. Good. Good, look at that. So now it works. We only had to add this thing. Well, to basically split the last part. Alright, now it should work. Yay! It was good that we had the solutions, so let me get the solutions. I don't want to waste them anymore. All right. What's the time? Okay, let's try to do one more, at least. How many we did? Like 3, right? Oh boy, they're getting harder and harder. Amicable numbers. Hopefully I pronounced that right. Let d of n be defined as the sum of proper divisors of n, numbers less than n which divide evenly into n. If d of a equals b and d of b equals a, where a different than b, then a and b are an amicable pair, and each of a and b are called amicable numbers. Okay, for example, the proper divisors of 220 are 1, 2, 4, da da da. Therefore, d of 220 is 284. Okay, so yeah, there the sum of the divisors, sorry, is 284. The proper divisors of 284 are 1, 2, 4, and, well, 1 to 4, 71, and 142. So that's that. Evaluate the sum of all the amicable numbers under n. Okay. Now, this is interesting. First, we kind of need to get the divisors. And then we need to add them up. And then check if the sum of the amicable number is that number. So we need to get d of n, well, d of x, which will be a number y, and then we need to check if d of y equals to x. Well, they used a and b. And if they are, we're going to add them to an array, and then we need to find the sum of all those. Okay. I feel like there are a lot of numbers here. I'm thinking, how can we speed this up? Okay, I guess we need to go over all the numbers, right? So find somewhere under n. Okay, so we start with 1. Is 1 an amicable number? D of 1 is 1. D of... maybe? Oh, no, because A and B are should be different. Okay, so 1 is not. What about 2? 2 with 2, no. 3 as 1 and 3 is 4. 4 is... let's see. So divisors of 3 are 1 and 3, which is 4. Divisors of 4 are 1 and 2, which is 3. So these are friends. Friendly numbers. Okay. What about 2? Has 1 and 2, which is 2. Which, well, 2 has 1 and 2. This is an infinite loop. But then A and B must be different. So we start with 3. Okay, good. Up to n I plus plus. Let's see. We need a function to check if is friendly. I can't pronounce this name, so I'll just call it friendly. If it's friendly, let me note. Friendly equals amicable. But Florin can't pronounce it. just so we have a note. Good. So if it's friendly I, then we want to have here const friendly numbers will be an array. If it's friendly, then the friendly numbers will push I. As simple as that. Now, how do we find if it's a friendly? Is friendly I. First, find all the divisors. So let divisors for let I, sorry, this let's make this n. I is 1, I less than equals to n divided by 2, right? Goes up to the number, well, up to the half of the number, I plus plus. If n modulus I is 0, then divisors that push I, right? So now we should have all the divisors. Goody goody, I think. Up to that. Oh, so many spaces and all that. So we start with that, we increase with 1, we check if it's divisible. Okay, if it is, we push there. Now we need the sum of divisors. We're going to use reduce, accumulator, item, well, number, and accumulator plus number start with 0. We get the sum. Good. Get the sum of the divisors. And now we kind of need to check if this is friendly. Well, I guess no, we need to get these numbers divisors, add them up and see if equals to this sum. Okay. Let's make another function. Sum of divisors of n. And this function will do this. Return this. Okay. Good. So find all the divisors and add them up. And now here, sum. Let's do const a will be sum of, sum of div of n, right? And const b, let's see. So we have the sum of divisions. This will be, again, I got a bit messed up here. So we have the divisors of the first number and the sum of them. And now we need to see if sum of divisions of A is B. Turn A equals B. Is that friendly number not defined? Where? Friendly numbers. Infinite loop. Why? Where? So let's think again. D of A will be B. So this will be A. Okay, let's use it like this. B will be div of A and A will be div of B. Yeah. And now, well, we're kind of resetting this. B divisors will be some divisors of B. And we need to check if, you know what, let's do it like this. I have a number here. B will be this, A will be that, and we need to check if A is equals to B, right? Let's see, console.log A and B. Feels right. I also want to see n, which is the number. So 3 has, let me select this, sum of the divisors of 3 is 1, and there the number, no, it doesn't count. Oh, okay. So the number itself won't count. So we have 1, and then sum of divisors of 1, well, it's 0, I guess. Good. Then here we have 4. 4 has 1 and 2, which is 3. 3 has 1. Okay. 5 has 1 and, well, 1, and 1 has 0. Good. 6 has 1 and 2 and 3, which is 6. Something's off. I feel like I'm missing something. Which is 6, but we don't. And then, yeah, A is B. We kind of need here. We messed up with the naming conventions because here we don't need to check if A is, well, A should be different than B. Okay. Let's slow down. So we have this number, right? Which is n. We want to get the sum of its divisors. And divisors. Okay, will be sum of n. Good. Now this, yeah, will be 284, which will be B. It says here, right? D of A, well, D of the number will be, and then we need to get the divisors of this one, and should be A. It goes into A. And if these are equal, that's good, although A and B should be different. So N and B. Okay, let's go to 220. Let's see what we get there. 220 is 284, and 284 is 220. So no, not A is B. We need to check if A is different than B, and N is equal to A. Let's go now back. So this is N, this is B, and this is A. These two numbers should not be the same, but N should equal to A. If we go to 284, we should see the same thing happening. Yeah, so N, B is different than A, but then N should be equal to A. Okay, good. So this is good. And this returns true or false. If it's friendly, we push. And let's see, friendly numbers. Line 4. No, it shouldn't be infinite loop. Console.log. We get these numbers and we need to add them up. Oops, something's wrong. For 1000, we get it right. Accumulator number, accumulator plus number, 0. So we get it right for 1000. We get it right for 2000. For 5000 we don't. Whoops. And neither for 10,000. Maybe it's something with the... Let's just run and see. Okay, so apparently it works. Maybe this console log is broken. Yeah, although this is the brute force approach. And one thing we could save would be here. Well, when we get a friendly number, we kind of know its partner, right? So we could store both of them. So then, for example, when we had 220 and 284, we already knew that 220 by checking here is a friendly number. We could also add 284. So then when we get to 284, we don't do the calculation again. But it works, so it's good. What every developer says, I guess. Okay, let's save this. And done. For today, I don't think we have time for another one. Let's look over it. And see what is it about. Using names, an array defined in the background containing over 5,000 first names. Begin by sorting it into alphabetical order. Then working out the alphabetical value for each name. Multiply this value by its alphabetical position in the list to obtain a name score. For example, when the list is sorted in alphabetical order, Colin, which is worth 3 plus, okay, is the 938 name in the list. So Colin will obtain a score of this. What's the total of all the name scores in the array? Okay. This shouldn't be that hard. So let's do it. Basically, we need to get, well, let's see, using names in an array, demo. Okay, begin by sorting it. So first you sort it. So array.sort. Okay, so first we sort it. A is only test this. This is only a test. Then we want to convert the strings into, well, the sum of the characters. So function sum of characters, we'll get a string, and here const sum is 0 for let I 0, I less than string dot length, I plus plus. And what we want here, we want to use the ASCII table, and we want to convert capital C to 3. So we need to, capital C is 67, we need to, well, subtract 64, right? Yeah, so A minus 64 is 1. 65 minus 64 is 1. Good. So 64 is our number. We want to get the character value. So string from char code string of I minus 64. This will be added to the sum. And we return the sum. Good. Now this will add the sum of the characters. If we go over this and use sum of characters, we should oops, this should be let. Not a number, not an hour. Perfect, that's what we want. What's happening here? String from char code. Oops, sorry, now this is the wrong function. We need to do char code at I. Good. So A now becomes, well, where is it? Here. Console.log array. So we have A is 1, is 28, and so on and so forth. And well, we do the map, sum of characters, and then we want to do another map to multiply with the index. So number and index. This will be number times index plus 1, right? For example, when the list is sorted, colon is worth like that, is the 9038 in the list. So we get the index times the score and we get the number. Good. So we map over, we get the number, we get the index, and we multiply the number with the index. All right, good. And at the end, we need to add up this thingy. So we can use reduce again. We get the number, we get the accumulator, the number, and we add it to the accumulator. Start with 0. And look at that. Done. Yay! It worked. I was afraid, but it worked. Well, you're always afraid with these kind of challenges. Good. So with a bit of help from the array methods, using the charcodate, then doing some conversions, we are done. And we did another one. Let's submit this. And we're going to have this one be the next one for probably next week. I hope you enjoy this. I'm sorry at the beginning it was harder. By we I mean I kind of messed it up, but indeed it was harder. I think it was the hardest problem we had so far. This one. Thanks to Lauren for helping, and also thanks to Duck for helping. We solved it. Okay. Lauren said that I think using the date function is a bit cheating. Yeah, for one of the problems. Oh well, but we did it. All right. Thank you all for watching. I hope you enjoyed it. If you did, give it a like and subscribe to the freeCodeCamp YouTube channel if you haven't already. Thank you all for watching, and I wish I wish you a good day. Bye.